At first light, Devil's Tower does not look like a mountain. It looks manufactured. A dark shaft of stone rises out of open country with vertical fluting so regular it seems less like geology than fracture in an object too large for the eye to measure. In old photographs, the scale becomes more disturbing, not less. Horses stand at the base, wagons cross the foreground, human proportion collapses. The thing is too straight, too isolated, too self-contained. It does not resemble a range, it resembles a remainder, and once that thought arrives, it becomes difficult to remove. If this is only a mountain, why does it look so much like the base of something that is no longer here? The accepted explanation is familiar. Mountains rise through uplift, faulting, volcanism, and intrusion. Stone cools, cracks, hardens, erodes. Softer sediment disappears. Harder rock remains. In this account, Devil's Tower is an igneous body exposed by millions of years of erosion, its columns formed by cooling fractures known as columnar jointing. Shiprock is treated as a volcanic neck. Mesas and buttes are remnants of resistant caprock, left standing after the land around them was stripped away. Petrified wood is simply wood replaced by minerals under the right conditions. Each feature belongs to a category. Each category has a name. Each name promises finality. And yet names can settle a question before the question has really been examined. Because what the official explanation does very well is describe process at the level of rock mechanics. What it does less well is account for why certain formations present such specific visual and structural echoes of biological form. That's why those echoes repeat at multiple scales and why they continue to provoke the same instinctive recognition in people who have never read the same theory, never visited the same site, never shared the same language. There is a point where resemblance becomes pattern and a point where pattern demands more than dismissal. The difficulty is deciding where that threshold lies. So the hidden theory begins there, not with certainty, but with a narrower and more serious proposition. That some formations now classified entirely as geological may preserve the mineralized or structurally transformed remains of organisms on a scale no longer admitted by standard history. That in at least some cases, mountains, towers, buttes, and root-like stone radiations may not be merely analogous to trees, but linked to a lost biological architecture whose original form has been buried under replacement, recrystallization, erosion, and reinterpretation. Not every mountain, not every column, but enough anomalies, enough repeated traits to justify real scrutiny. Start with shape, because shape is the first thing the eye detects and the last thing a classification can fully erase. A tree trunk narrows with height, carries vertical grain, and often terminates in an exposed base after surrounding material is removed. Many isolated towers and buttes do something similar. They stand not as jagged accumulations of broken blocks, but as singular uprights. Some are ringed by talus that resembles splintered rind. Some display fluted faces that look less like random fracture than bundled fibers pulled vertical through one body. Geology says cooling rock cracks in prismatic forms. That is true, but what remains striking is not that columns exist, it is the scale at which the trunk-like impression survives after immense damage. The eye keeps returning to the same conclusion. This does not look assembled, it looks amputated. Then there is the matter of proportion. Ordinary petrified wood exists. No one disputes that. Entire fossil forests have been catalogued. Stone logs dozens of meters long and several meters across are already within the accepted record. That matters because it establishes the first boundary condition. Wood can mineralize, cellular structure can be preserved in stone. Tree scale life can endure as rock. Once that is admitted, the argument is no longer over whether biology can enter geology. It plainly can. The argument becomes one of scale and classification. At what size would a petrified organism cease to be recognized as an organism at all? At what point would experts stop looking for anatomy and begin naming landforms? Measurements sharpen the unease. Consider the famous towers with near vertical sides and repeated polygonal fracture. In conventional geology, the hexagonal pattern comes from contraction during cooling. Again, that is a real process. But in biological systems, hexagonal and near hexagonal packing also appears wherever growth, stress distribution, and efficient division of space overlap. Honeycomb, plant tissue, cellular mineral textures, branching vascular bundles under pressure. Similar geometry does not prove common origin. It does, however, eliminate the lazy comfort of saying that a shape is self-explanatory. Hexagons are not an answer. They are a clue that energy organized matter under constraint. The question is what kind of system produced the constraint in the first place. Maps deepen the problem. Look not only at one tower, but at regional layouts. There are places where a central mass stands isolated while ridges, dikes, or radial lines extend outward, like roots or buttressing supports. Shiprock is famous for this. The standard reading is volcanic, a neck with radiating dikes cutting through surrounding rock. But step back from the label and look at the form. A central column, thin stone sheets extending outward, a footprint that suggests not only eruption but anchoring. The official explanation can describe how magma exploits cracks and hardens into walls. So what it does not explain away is why the resulting geometry so often resembles a base structure rather than a random remnant. The pattern repeats. The pattern does not disappear. Old photographs add another layer because they preserve landscapes before tourist infrastructure, before modern grading, before interpretive signage taught the public what to see. In many 19th century images of buttes, towers, and stone columns, the formations appear even stranger than they do now, not because the rock has changed, but because the human mind had not yet been so fully trained into geological categories. Early observers called such places tree rock, bear lodge, petrified forest, stone stump. They were not all making technical claims. Often they were naming by resemblance, but resemblance recorded before theory is valuable. And it shows what an uncoached eye noticed first. What changed was the explanation. The mainstream explanation deserves to be stated fairly because it is not foolish, and many fringe arguments survive only by caricaturing it. Columnar jointing is real. Volcanic necks are real. Differential erosion is real. Laccoliths, plugs, sills, and intrusions are not excuses invented to protect doctrine. They are well-documented features with measurable properties. There are places like Giant's Causeway and Devil's Postpile where cooling lava clearly produced ordered stone columns. There are formations where internal chemistry, contact relationships, and surrounding deposits strongly support igneous origin. All of that matters. But what matters just as much is what the mainstream model often leaves unresolved in the public imagination. Why some formations combine these mineral processes with silhouette, taper, surface texture, and landscape context so suggestive of organic form that the resemblance feels less accidental than convergent. The standard model explains the rock. It does not always explain the whole impression. That distinction matters because scientific closure often happens at the first adequate mechanism, not the last complete interpretation. If cooling fracture can account for the columns, inquiry stops at the columns. If erosion can account for the exposure, inquiry stops at exposure. Yet a structure can contain more than one history. Replacement can preserve form while altering substance. Fossilization itself is proof of that. Petrified wood is no longer wood in chemistry, but it remains wood in architecture. The grain can persist. Growth rings can persist. Vessel patterns can persist. The original material is gone, but the shape survives through substitution. The stone remembers. So when a landform retains a biological logic after being declared entirely geological, the careful response is not ridicule. It is comparison. Comparison is where the theory grows more serious. Examine cross-sections of mineralized wood under magnification, and the transition from organic tissue to stone is not clean. Silica moves through voids. Cell walls become templates. Pores fill. Original matter decays, while a mineral ghost takes its place. Now widen that process beyond logs lying in sediment and ask a destabilizing question. If entire forests can be entombed, silicified, compressed and re-exposed over vast spans of time, what would the remains of far larger arboreal systems look like after tectonic pressure, hydrothermal alteration, and differential erosion had worked on them for ages? Would we still expect bark and branches, or would we expect columns, plugs, dikes, breccia, and confused mineral signatures layered over a form no one thinks to test as biological because the scale is considered impossible? The difficulty is scale, and scale does not merely challenge evidence, it challenges permission. Modern natural history has boundaries for how large trees can become, based on fluid transport, gravity, biomechanics, atmospheric chemistry, and observed growth. Those limits are reasonable within current conditions, but they are still model-based limits, not eternal laws handed down outside time. Earth has not always offered the same atmosphere, the same pressure, the same ecology, the same competition, or the same catastrophe regime. Giant fungi once stood where no forests like ours existed. Insects reach sizes now impossible. There were ecosystems built on rules no longer active. Once that is admitted, the statement such trees could not have existed becomes weaker than it first appears. The real statement is narrower. They could not exist now under assumptions we currently treat as stable. Landscape similarity widens the case from a single curiosity to a repeating pattern. Across Wyoming, Utah, New Mexico, Arizona, parts of Siberia, Australia, Southern Africa, and the American West, there are isolated masses that share the same visual grammar: truncated vertical bodies, fluted sides, exposed radial outworks, are caps that resemble cut surfaces surrounding debris fields that read like shattered fibrous material. Not all are the same formation type in official geology. Some are volcanic, some sedimentary, some metamorphic. But the visual family persists across categories. That is precisely what makes the theory unsettling. If the resemblance belonged only to one rock process, it could be contained within that process. Instead, the resemblance crosses labels. The pattern repeats under different names. There is also the matter of missing infrastructure. If some of these giant isolated structures are merely resistant remnants, then one expects more visible transitional forms connecting them to the larger systems that produce them. Sometimes those transitions exist, often they do not. Our towers stand alone in planes that seem insufficient to explain their dramatic isolation. Caprock models explain some mesas well enough, but less so the almost theatrical singularity of certain monuments. Erosion is patient, but it is not magical. It removes according to material, slope, climate, drainage, and time. When a formation survives as a solitary giant, while the supposed parent structure vanishes almost completely, the explanation may still be correct. But it becomes more dependent on unobserved deep time and less intuitively satisfying in the visible record. What remains asks for more than a label. Patents, surveys, and institutional records contribute in a quieter way. Modern forestry, mining, and geology define matter by use. A forest is timber. A mountain is ore, hazard, watershed, reserve. Bureaucratic categories are practical before they are philosophical. Once a mass is entered into a survey as basalt, phonolite, breccia, sediment, or intrusive body, every later question is routed through that original filing system. Funding follows discipline. Samples are taken for mineral content, not for residual cellular geometry at absurd scales. Remote sensing looks for faults, magma chambers, water tables, and extraction potential. No agency is built to test whether a mountain is the mineral ghost of biological architecture, not because someone is hiding it in a locked vault, but because the category itself is inadmissible. Bureaucracy can erase a possibility simply by never designing an instrument panel for it. Now, this is where the theory leaves the territory of dramatic conspiracy and enters something more plausible and more durable. Inertia. Classification hardens, textbooks stabilize, careers are built within a model, not outside it. A geologist can spend a lifetime studying a formation's chemistry without ever being professionally rewarded for asking whether its overall morphology echoes a petrified organism. An archivist can catalogue strange 19th century descriptions as folklore. A land manager can translate indigenous naming traditions into mythology rather than observational memory. A mining company can blast through unusual structures because ore grades matter more than ontology. The truth, if there is one here, would not need to be hidden by a cabal. It could disappear into paperwork, disciplinary boundaries, and the simple force of prior explanation. Indigenous memory deserves attention, not as proof but as a stubborn archive of pattern. Around many dramatic stone monuments, older names and stories describe trunks, lodges, claws, trees, living pillars, beings turned to stone, or places where the land was once different in kind, not only in shape. A modern ear hears myth and stops, but myth is often compressed observation carried through sacred language. It is memory encoded in forms official history no longer treats as evidence. This does not mean every story is literal geology. It means the archive is larger than state reports. When multiple cultures independently attach biological or once living significance to singular stone forms, the coincidence should at least be logged. The record is still there. And even the debris fields around some suspected stump-like formations deserve a second look. Geology reads them as tarlous, scree, collapsed blocks, weathered fragments. Often that is exactly what they are. But in some places the fragment morphology produces another unease. Elongated shards, splinter-like pieces, radial break patterns, and stratified flakes that look less like random collapse than torn bundles. Again, resemblance alone is weak evidence, but documentary investigation is built from accumulations of weak evidence that point in one direction, not one analogy. 10. Not one strange shape, a family of them, not one site, a distribution. Then there are mountains themselves. The title claim is deliberately excessive. Beneath every mountain, taken literally, it fails at once. Our mountain systems have multiple origins and no single hidden answer. But taken as an investigative provocation, it points towards something harder to dismiss. Beneath many mountains lies buried organic history on a scale the public barely contemplates. Coal seams are compressed forests. Limestone mountains are the transformed bodies of marine life. Oil is ancient biomass rendered into chemistry and pressure. Entire landscapes are already known to be cemeteries of former ecosystems. The planet is built from prior life as much as from sterile rock. Once that becomes clear, the distance between mountain and fossil narrows. The strange theory begins to feed on a true foundation. Earth is not simply covered with dead worlds. In places, it is made of them. What unsettles people about the giant tree hypothesis is not only that it sounds strange, and it is that it reorganizes familiar scenery into aftermath. A mesa becomes a cut surface, a tower becomes a trunk, a dike becomes a root flare. Petrified forests stop being local curiosities and become miniature demonstrations of a much larger principle. That life can be mineralized so completely it passes into geology while preserving enough form to haunt the eye. If that principle has been encountered only at small scales, perhaps that is because small scales were the only ones anyone was willing to name. And still, caution is necessary. A good investigation resists the thrill of total explanation. Some towers are almost certainly volcanic. Some columns are unquestionably cooling fractures. Some stump-like silhouettes are coincidence sharpened by erosion and human pattern recognition. However, the theory does not gain credibility by swallowing everything. In fact, it becomes stronger when it narrows. The serious version does not say all mountains were trees. It says our categories may be too rigid to recognize when biological form survives inside geological process, especially at scales deemed impossible before testing begins. That is a very different claim, and it is one the present system is poorly designed to examine. Because what would serious examination actually require? Comparative morphology across isolated towers and confirmed petrified wood. Thin section analysis aimed not merely at mineral identity, but at large-scale structural repetition. remote sensing of radial formations to distinguish purely igneous emplacement from patterned anchoring geometries. Our historical analysis of early photographs before restoration and blasting altered surfaces. Indigenous place name studies treated as observational data rather than decorative legend. Funding for questions that would embarrass existing categories if the answer were even partially affirmative. None of this is irrational, it is simply unfashionable. That may be the most revealing fact of all. Extraordinary resources have been spent mapping ores, groundwater, seismic risk, petroleum basins, and volcanic hazards. We have bored into ice sheets, scanned buried cities, traced neutrinos through mountains, and modelled ancient atmospheres from microscopic bubbles. The tools exist, the archives exist, the formations stand in plain sight. What is missing is not capacity, it is permission. How much permission to ask whether some landscapes are not only older than we think, but stranger in kind than the modern mind is comfortable allowing. So return to the tower in the morning light. Return to the butte cut flat against the sky. Return to the mountain whose exposed radiations look uncomfortably like buried structure. The point is not to abandon geology for fantasy. The point is to notice how often the land presents forms that geology can describe in mechanism, while leaving their larger resemblance untouched. There is an official explanation. There is also the residue left after the explanation ends. That residue is where hidden history begins. Perhaps these are only mountains, and our pattern-hungry minds are doing what human minds have always done, reading life into stone, perhaps. But perhaps the opposite error is now more common, reading only stone where the deeper history of life has already been mineralized beyond easy recognition. In either case, the same fact remains. The question has been mocked far more often than it has been tested, and the real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked.